All right, so let's talk about low angle rope rescue. So really what we're talking about here is utilizing rope and hardware in order to do two things. Number one, get somebody out of a difficult position with some degree of increased safety, and the other is to add mechanical advantage to our ability to move someone out of a difficult situation. We utilize at the National Winter Activity Center a CMC rope rescue kit, which has all the materials to do a mechanical advantage system for a low angle haul. If you pan down over here, you can see our sled downhill in a place to where we wouldn't be able to ski it out. If a patient were injured down there, we would want to be able to haul them up, and we want to haul them up with a minimum of effort and a maximum of safety. So when we take the rope out of the bag, we've got 150 feet of rope here. The first thing at the top, just like our lift evac bags, is all the hardware. So you've seen what we did here is we took the hardware out and we hung it somewhere where it's not going to get buried in the snow, it's not going to get wrecked. We've got our webbing to create anchors or harnesses, just like in a lift evac bag. We have prussics in order to provide brakes. We've got a rescue 8, just like in the lift evac bags. This would be for lowering someone down as opposed to hauling somebody up. We have a bunch of identical locking carabiners. So all this stuff is here. And then you can see that we've rigged a system already that shows how we would most commonly bring somebody up a slope. So the good news is that we leave this pre-rigged. So you don't have to reinvent the wheel if you need to use this in a pinch. But let's talk about the pieces of this. Number one, we have an anchor. In this case, we have a secure tree as the anchor. We're down as far as we can on the tree, the closest to the ground where the tree is the strongest. And we have an anchor that's indirect, wrapped around the tree, equalized, and comes to this beaner here, which is locked. We have our plate here, which allows us to put multiple things on the beaner. And then we've got a 3-to-1 mechanical advantage system. So the end is attached to the toboggan. That rope comes up through this pulley, goes back down through another pulley on a prusik on the rope, which causes the haul, and then comes back up here, which is where we put the manpower. Ski Patrol, go ahead. Okay, so when we're hauling up, I don't know if you can see that from the camera angle. So the prusik is going to grab onto the rope. The prusik has the pulley attached to it. So we're pulling the pulley, which is pulling the prusik cord, which is grabbing the rope and hauling the sled up. Then the rope is coming back through here and threading through a second pulley that's on our anchor. And this plate also has, as a safety backup, a prusik already pre-rigged on it. Now this prusik is loose. So as the rope goes through it, this will passively move. If for whatever reason the people doing the haul let go, let's say they all fall down, then this prusik is going to grab. It's going to tighten up, and it's not going to allow this rope to go back. So the patient will stay exactly where they are on the mountain. So all of this is a huge advantage to us because working in ski boots on a slope in the snow, things are a little bit precarious, and this gives us a measure of safety. A couple things to show you here. Again, we have a variety of tools in here. We went heavy on the webbing, we went heavy on the carabiners and hardware to give us as many options as possible when rigging this, because sometimes you can't forecast exactly how this is going to look. I want to show you okay, so with everything set up, now it's time to haul. So we're attached to the front. We've got our mechanical advantage system. This is 150 feet of rope. You can see that we have a 3-to-1. That means that our available rope is effectively divided into thirds. However, the prusik is movable. Now we've slid the prusik that's going to haul this system all the way down to where the sled is, which makes it easy. But if we didn't have enough rope, then we could move that prusik dynamically during the course of this rescue and haul a little bit at a time and maximize the length of our rope. And actually, Jacob, if you could join me. So we are going to haul this sled up. Now obviously there's going to be a patroller attending the patient, but we are going to walk uphill with this rope and we're going to haul the sled. Now we're going to give an example. Okay, Jacob, let go. Right? Okay, so again, if we need a longer rope than we have in thirds, then we can pull up the patient incrementally. So what happened here is we brought the prusik to about where we need it to be in terms of a working space. You can see this is flatter than the slope that I'm working on. What we can do at this point is slide the prusik back. Now you'll notice I've got my hand on the carabiner. I do not have my hand in the pulley because I don't want my fingers to end up inside where the working part of the pulley is. But I can slide this back to here, and then Jacob can start taking it up again. And we'll haul this piece by piece. So the prussik's gonna grab, he's gonna haul. All right, he's gonna stop, that prussik's gonna bite. Let it free flow out of your hands now that that's anchored. There we go. So that prussik's anchored. I bring this back to my working space. Okay, and Jacob goes again. Okay, stop. All right, let it free flow through your hands. I'm gonna let this prusik go. I'm gonna let that prusik bite, which it does. All right, take the rest of the way up, Jacob. Cut. We're using mechanical advantage to bring this sled uphill. We can either just grab the rope with a couple of us and walk uphill, and that will haul the sled, or we can obviously stay in place and take up the rope and give it a pull because the mechanical advantage should make it relatively easy. Now let's say something goes wrong. Let's say I'm hauling this up and then I fall and I let go of the rope. So what happens? Well, if the sled gets weighted, then the system will break. Okay, let's talk about lowering. So let's say we're in a position where we need to lower the toboggan down to a safe place. So as opposed to needing mechanical advantage at this point, what we really need is some assisted braking and a measure of safety. So for this, we're using a Rescue 8 with the ears here. Again, same as lift evac, we've got that rigged. And for the sake of this system, we also have a prusik as a backup, which will need to be minded. So whoever is minding this system over here will need to keep a hand on the prusik in order to make sure that it doesn't constantly grab. However, it's passive protection. So if for whatever reason the people managing the system fail, this prusik will grab and it won't allow it to slide out of control. So otherwise, it's just like any type of belay system. It gets managed. How do you allow it to free flow? Right? Keep the ends of the rope near each other. How do you get it to stop? You pull the ends apart. Okay. Okay. So in order to undo the webbing, you just take one piece out and then pull it. It'll come out to be one piece of webbing with a water knot in the middle. The various pieces of webbing are color-coded for length. when you put webbing onto an anchor, you want to make sure that this is equalized. So the way I like to do it is you go around, right, again, and we set it up. So again, this is as low as possible on the tree. We want to be as close to the ground as possible. And we want these two ends to be equalized so that when we put a carabiner on it, that carabiner equalizes the load across this and then across the back of the anchor. And then we'll tighten the locking carabiner in order to make the anchor. Now, all right, so we really have two options to connect to the system. We can either tie directly into the rope or we can tie in with a prusik. So recommended knot for tying in is a butterfly. So you can see I'm wrapping 3 times around my hand. I'm taking the middle, coming through and back again, which gives me an omnidirectional knot at the end. Okay, so what happens if you as a patroller need some degree of fall protection as well because of the sketchiness of the slope? Well, we know how to tie a hasty harness from our lift evac. So why don't we start by doing that? So knot to the back on a piece of webbing. That's going to the small of the back. Then we're reaching through our legs. Grab, grab, tighten. Okay, gives us a nice harness. And then if necessary, we can tighten it up and knot it in order to create an equalized anchoring point. Then we're going to take our carabiner and we're going to tie in. We can either tie in directly to the rope with a knot, or we can put a prusik onto the rope and tie into the prusik, which gives us the same degree of passive protection as the system itself. Why don't we go over to the rope and we'll see how that works. You pre-rigged, but if you need to rig something yourself, a prusik goes around 2 or 3 times. And then again, it should grab this way or it should grab this way. It'll provide friction